This is the OCR GCSE 9-1 Maths Paper 5 from the higher tier, and it's from the November 2020 series, and this paper is a non-calculator paper. Question number 1. We have to write 75 as a product of its prime factors. We begin with the 75. Two numbers which multiply to give 75, one of them being a prime number. We have 3 and 25. 3 is a prime number, 25 isn't, so we can further split up the 25 as 5 multiplied by 5. And so therefore, what you will find is 75 is equal to 3 times 5 times 5. So we end up with 3 times by 5 squared. So we have 3 times by 5 squared. Question number 2. For part A, we have to solve 4x plus 3 equals 13. We begin by subtracting 3 from both sides, leaving us with 4x equals 10. And now if we divide both sides of the equation by 4, we end up with x equals 10 divided by 4, which is 2.5. And so therefore, you will find x to equal 2.5. And now for part B, we have to multiply out and simplify 5 lots of 2x plus 3 plus 2 lots of x minus 4. Multiplying out the brackets, 5 times by 2x is 10x, 5 times by 3 is 15, 2 times by x is 2x, 2 times by minus 4 is minus 8. 10x plus 2x is 12x, 15 minus 8, that's 7, and so the result of all this is 12x plus 7. Question number 3. For part A, the ratio of 45 minutes to 3 hours 45 minutes can be written in the form 1 to n. We have to find the value of n. You will notice here we have hours and we've got minutes elsewhere. We need to begin by getting the units the same. We know that in 1 hour there are 60 minutes, and so therefore in 3 hours there are 60 multiplied by 3, which is 180 minutes. And so in 3 hours 45 minutes, the total number of minutes we've got 3 hours, which is 180 minutes, plus 45 minutes. We have 225 minutes. And so therefore, we need to express the ratio 45 to 225 in the form 1 to n. So, from 45 to the 1, we divide by 45, and 225 divided by 45, we end up with 5. So, the value of n is equal to 5. For part B, Reese and Sarah share some money in the ratio 9 to 16. Reese says that Sarah gets more than 60% of this money. Show that Reese is correct. Well, Sarah, she would get 16 out of 9 plus 16 in total. And if I multiply this by 100, well, 16 over 9 plus 16, that is the same as 9 over 25. And then I multiply that by, rather, we have 16 over 25 multiplied by 100. You will find this is the same as 16 multiplied by 4, which is equal to 64. Sarah gets 64% of the money, which is indeed greater than the 60%. And so we can conclude over here that Reese is correct. Question number 4. Dora has the following number cards, what we see here. She takes a card at random, replaces the card, and then takes a second card. She adds the numbers on the 2 cards she has taken and records the total. For part A, we have to complete the following table to show all of her possible totals. We've got the first card and the second card. Well, what we need to do here is add together the score from the first card and the score from the second card. 5 plus 2 is 7. 3 plus 3 is 6. 2 plus 5 is 7. Here is the completed table. For part B, we have to find the probability that her total is, for the first part, an even number. Well, how many numbers do we have in total? Well, we've got 25 numbers in total. And of those 25, how many are even? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 numbers out of 25 which are even. Next, we are looking for the probability that the total is a multiple of 3 or 4. Well, 4 is a multiple of 3 or 4. So is 8. 9 is a multiple of 3. 6 is a multiple of 3. 12 is a multiple of 3. We have 14 numbers selected out of a total of 25. So we have 14 divided by 25 as our probability. Question number 5. Charlie and Jasmine share cartons of apple juice. Charlie drinks 1/3 of a carton every day. Jasmine drinks 2/5 of a carton every day. Any apple juice left in a carton at the end of the day is used the following day. The cost of a carton is 70p. Charlie and Jasmine buy just enough cartons to last them for 10 days. How much do they need to spend in total for these cartons? Give your answer in pounds. Show you're working. Well, let's find out how much they drink every day. They would drink every day, well, we've got 1/3 plus the 2/5. And if we work out what this is, well, if I write them over a common denominator of 15, then we have 1 times 5, which is 5, 2 times by 3, which is 6, so we end up with 11 over 15. So this is how much they drink every day. And so in 10 days, how much would they drink in total? Well, we would have 10 multiplied by 11 over 15, which is equal to 110 over 15, which simplifies to 22 over 3. In other words, we've got 7 and 1/3, which is how much to drink in total. And so, how many cartons do we require? We see in total 8 cartons are required. We round this up to 8 cartons. And so therefore, the cost of this, if one carton costs 70p, in other words, 0.70 pounds, we multiply this by 8, and then you can see the cost is £5.60. So we have £5.60. Question number 6. A clock chimes every 20 minutes. A light flashes every 8 minutes. The clock chimes and the light flashes together at 8 o'clock. How many times between 8:01 and 12:30 will the clock chime and the light flash together show you're working? We need to first of all find the lowest common multiple of 20 and 8. This allows us to find out how often they chime and flash together. And the lowest common multiple of 20 and 8 is 40. And so what we can conclude from here, they flash together every 40 minutes. So if we start off at 8 o'clock, 40 minutes after this we have 8:40, then we have another 40 minutes, so that takes us to 9:20. 40 minutes after this we've got 10 o'clock, another 40 minutes we've got 10:40, another 40 minutes we've got 11:20, and another 40 minutes we've got 12 o'clock, and then we've got 12:40. Now what we are looking for is how many times between 8:01 and 12:30 do they chime and flash together. Well, we've got 1, 2, 3, 4, 5, 6. So they chime and flash together 6 times between 8:01 and 12:30. Question number 7. A pattern is made from 4 congruent right angle triangles. Well, all this means is that all the right angle triangles we see here are the same. The line AC is parallel to the x-axis, and the point A has coordinates 4, 9, and the point B has coordinates 17, 12. We have to work out the coordinates of the point C and the point D. Well, if we take a look at how we go from the y coordinate of A to the y coordinate of B, we are going from 9 to 12. So between here, we've got 3. 9 plus 3 gives the 12. And so this side here is 3 of our triangle, which means here to here, we've got 3. And here to here, we also have 3. Next, we can find out the missing length here. 17, take away 3, take away 3, take away something else is 4. Well, that something else will be 7. 4 plus 3 plus 3 plus another 7, that's 17. So, from here to here is also 7, and here to here we also have 7. So to find out the coordinates of D, well, we've got 4 plus 3 plus 3, that's 10. And then 9 take away the 7 is 2. Next, to find the coordinates of C, the y coordinate will remain the same, AC is parallel to the x-axis. But for the x coordinate of C, 4 plus 3 plus 3 plus 7 plus 7, that's 24. And then y coordinate is 9. So we have figured out the coordinates of C and D. We have the coordinates of C, 24, 9, and the coordinates of D, 10, 2. Question number 8. A weather forecast says the probability that it will rain on Monday is 0.55 and the probability that it will rain on Tuesday is 0.25. Ella draws a tree diagram to show this information, and we have to write down 3 errors that Ella has made with her tree diagram. Well, if we take a look at Monday, then the probability that it does not rain should be 1 minus the 0.55, which is 0.45. Here we got 0.35. That bit's incorrect. And then if we take a look at Tuesday, well, we mentioned that the probability that it rains on Tuesday is 0.25. So this has been placed incorrectly. So for Tuesday, 0.25 is incorrectly placed on the does not rain branch. Next, we are missing a branch after does not rain on Monday. So a pair of branches is missing for Tuesday after does not rain on Monday. Question number 9. In this diagram, AB and CD are parallel lines of equal length, and what we have to do is prove that the angle DAB, that's this angle here, equals the angle BCD, the angle here. That's what we want to prove. First of all, the angle ABD, that's this angle here, will equal the angle CDB. That's this angle here. So the angle ABD is equal to the angle CDB, and that's because they are alternate angles. We can also see that this length over here is common to both triangles. So let's just write down that reasoning. BD is common to both. And we know that AB is equal to CD. So that sentence was given to us already. So AB equals CD, and that was given. And so what we can conclude over here is we have side angle side, and therefore the triangles are congruent. And what we can therefore conclude, because the triangles are congruent, meaning that the triangles are the same, the angle DAB is equal to the angle BCD. Question number 10. Each day, Eve records how long it takes her to complete a puzzle. On Friday, she took 50% less time than on Thursday. On Saturday, she took 20% less time than on Friday. On Saturday, she takes 36 minutes to complete the puzzle. How many minutes did she take to complete the puzzle on Thursday? Show your working. Well, if we let x equal the time spent on a puzzle on Thursday, then on Friday she took 50% less time than she did on Thursday. So on Friday, the time she has is equal to 0.5 x. And then we know on Saturday she took 20% less time on Friday, so we have 0.8 multiplied by 0.5x. So this is how long it took her on Saturday. So Friday, 50% less time. And then Saturday, we've got 20% less time. And so therefore, if we work all of this out, what we can do is recognize that the time here, the 0.8 times 0.5x, is equal to 36. That is because on Saturday she took 36 minutes to complete the puzzle. So if I find out what x is, well, 0.8x is equal to 36 divided by 0.5, which is 72. And I know that 0.8 is the same as 4/5. So therefore, 4x over 5 equals 72. If I divide through by 4 and multiply by 5, then you will find x to equal 90. So the time she spent on Thursday, we've got 90. Question number 11. For part A, we have to work out 6 to the power of minus 1/2. Well, this is the same as 1 over 16 to the power of 1/2, which is the same as 1/4. Part B of the question, we have to simplify root 6 times root 3. Well, root 6 is the same as root 2 times 3. And I'm multiplying this by root 3. So using the laws of surds, this is the same as root 2 times root 3 times root 3. So I've got root 2 times by 3, which is 3 root 2. So I have 3 root 2. Question number 12. The price p pounds of a car is 20,000 in 2019. The price is expected to decrease by 5% each year after 2019. For part A, Jasmine says, This means the price in 2021 is expected to be £18,000. She is incorrect. Explain her error and work out the correct answer. Well, she has reduced the price by £1,000 each year. So when we come to work out the correct value, in 2021, the value is equal to, well, we've got our original amount, 20,000, multiplied by, well, if we're decreasing by 5% each year, our multiplier is 0.95, and then 2019 to 2021, that's 2 years, so we raise this to the power of 2. Now, this is what we need to work out. Now, if I work out what this is, if I work out 10% of 20,000, that's equal to 2,000, and therefore 5%, that's equal to 1,000. So therefore in 2020 the value is 20,000 take away the 1,000, which is 19,000. Now, if we work out the value in 2021, so let's just move this here, the value of the car in 2021, what we need to do here is work out 5% of 19,000. So first of all, 10% of 19,000 is 1,900, and therefore 5% is equal to half of this, which is 950. And therefore, in 2021, the value is 19,000 take away 950, which is equal to 18,050. So the correct answer is 18,050. And then we have to write down in a formula for P in terms of n, where n is the number of years in 2019. Well, we've got our original amount, 20,000, and then we multiply this by 0.95 to the power of n, where n is the number of years after 2019. And then we have to circle the graph that best represents the price, p pounds, of the car n years after 2019. Well, we've got a exponential graph, so we circle the graph over here. Question number 13 for part A, we have to sketch the graph of y equals sin x for x being in between 0 and 360. Here is the graph of y equals sin x between 0 and 360. For part B, the graph of y equals cos x minus 30 for x being in between 0 and 360 crosses the x-axis in 2 places. We have to write down the values of x where this occurs. Well, here is the graph of y equals cos x. So far, it crosses the x-axis at 90 and 270. Now, the graph of y equals cos x going to the graph of y equals cos of x minus 30, what we have here is a translation by vector 30, 0. We need to shift this graph 30 units to the right. So if I've got this graph here, I need to shift it 30 units to the right. So if I split this up even further, well, it will move around this much, okay? And then the graph goes back down like that. And then let's just rub this out. So here we've got the graph of y equals cos of x minus 30. It's been shifted 30 to the right. So here, where it crosses, I add on 30 to this to get 120, and I add on 30 to this to get 300. So it crosses the x-axis at 120 and 300. Question number 14. You have to simplify for part A, 4a to the power of 1/2 times 3a squared. This is equivalent to, well, 4 times by 3 is 12, and then we have a to the power of 1/2 plus 2. So we have 12a to the power of 5/2. And therefore, the expression simplified, we end up with 12a to the power of 5/2. For part B, we have 2a squared divided by a to the power of -3, all cubed. First of all, if we deal with what's inside the bracket, we have 2a to the power of 2 minus -3 cubed. So we have 2a to the power of 5 cubed. So we have 2 cubed times by a to the power of 5 cubed. So we have 8a to the power of 15. 8a to the power of 15. Question number 15. We have to solve x over x plus 6 equals 5. If we multiply through by x plus 6, we end up with x equals 5 lots of x plus 6. So we have x equals, well, 5 times by x is 5x. 5 times by 6 is 30. So we have x equals 5x plus 30. Rearranging, 4x is equal to minus 30. X is minus 30 divided by 4. We have 15/2 multiplied by -1. So we have x equals minus 7.5. Question number 16. The masses m kilograms of some parcels are shown below. Jack constructs this group frequency table to record the masses. That's what we see here. And we have to explain why Jack's table is unsuitable to record the masses. Well, what you see here is both inequalities are less than or equals to when one should be. Now for part B, the histogram summarizes the times taken in minutes by some students to complete a race. That's what we see here. We have to show that 70 students took between 45 and 70 minutes to complete the race. So between 45 and 70, the area here, we have 5 multiplied by 6, which is 30. Here we've got 20 multiplied by 2, which is 40. And so therefore, what we have is 5 times by 6, and we also have 2 times by 20 being added together. So we have 30 and 40 being added together, which is equal to 70. Next, we have to calculate an estimate of the mean time taken to complete the race. Show your working. So if we go back to the histogram, what we need are the midpoints and the associated frequencies. If I find out the frequency here, we've got 10 multiplied by 1, which is 10. Here we've got 5 times by 4, which is 20. So we've all got the frequencies. The midpoints, we've got 35. Here we've got 42.5. Here we've got 47.5. And here we've got 60. So for us to calculate our mean, we have the 10 multiplied by the 35. We have the 20 being multiplied by 42.5. We've got the 30 being multiplied by 47.5. And we've also got the 40 being multiplied by the 60. And we need to add all this up. And then we need to divide by the sums. So we need to divide by 10, 20, 30 and 40 all being added together. So therefore this is what the mean is equal to. So if we work this out, on the top we end up with, I'll work this out, on the top we end up with 350 plus 850 plus 1425 plus 2400. And on the bottom, the sum of the frequencies, we've got 10 plus 20 is 60, is 30 plus another 30 is 60 plus 40 is 100. So on the bottom we've got 100. So we end up with 5025 divided by 100, which is 50.25. So we have 50.25. Question number 17. The graphs of y equals x and y equals minus 2 are shown on the grid. The region R satisfies the following inequalities. We've got y being greater or equal to minus 2, y being less than or equal to x, and y being less than 4 minus 2x. By drawing one more line, we have to find and label the region R. Well, first of all, we need a dotted line. The reason we need a dotted line is because of the strong inequality. Now, it passes through 4 and it's got a gradient of minus 2. So, with that in mind, passes through 4, a gradient of minus 2. So, for every 2 we go down, we go 1 across. So here we've got a gradient of minus 2. You can see that over here. We've got our change in y, minus 2, change in x, 1. So the gradient there is minus 2. And we want y to be greater or equal to minus 2. So that's everything. If I grab the highlighter, that's everything above this line. Then we've got y being less than or equal to x, so everything below the line. So that is everything over here. And then we have y being less than 4 minus 2x. So that is everything underneath, as we see here. So the region we want, which satisfies all those, is the region shown here. So let's just show that. So here is our region R. Question number 18. The diagram shows a triangular field PQR, which is used to grow organic carrots. PQ is 100 meters, PR is 80 meters, and the angle RPQ is 30 degrees. In recent years, an average of 2.5 kilograms of carrots have been harvested from each square meter of the field. We have to use this information to work out the total mass of carrots that might have been harvested from the field in 2019. First of all, we need to find the area. The area of the field, we've got 1/2 times by 80 times by 100 times by the sine of 30. We've got 800 divided by 2, which is 400. And then timesing that by sine 30. Well, sine 30 is 1/2. So here we end up with 100 meters squared. And what we now, just double check this, half of 400 is 200 meters squared. And then we've got an average of 2.5 kilograms of carrots from each square meter. So therefore, the total mass, we've got 2.5 kilograms per square meter being multiplied by 200. So we end up with 5,000 kilograms. So we've got 5,000 kilograms. Now, we have to explain for part B why the answer to part A may be unreliable. So, conditions for growing may have been different in 2019, such as extremes in weather, diseases in the carrots, etc. Question number 19 for part A, we have to write x squared minus 10x plus 22 in the form x minus a all squared minus b. Well, here we need to complete the square. So we've got x minus 5 all squared minus the square of 5 plus 22. So I've got x minus 5 squared minus 25 plus 22. We end up with x minus 5 squared minus 3. So we end up with x minus 5 all squared minus 3. And now we have to sketch the graph of y equals x squared minus 10x plus 22, show clearly the coordinates of any turning points and the value of the y-intercept. Well, for the turning point, the coordinates of that, we've got 5 minus 3. Those are the coordinates of the turning point. So, what we need to do is begin by drawing the graph of y equals x squared. Like that. And then, we're translating this graph. We've got 5 across, minus 3 down. And if I take a look at where the y-intercept will be, that will be at 22. Over here. And we've got our turning point over here. So we've used transformations to sketch the graph. We've got the graph of y equals x squared minus 10x plus 22 shown here. The turning point must be in the fourth quadrant. Question number 20. ABCD is a trapezium. The perimeter of the trapezium is 56 centimeters. The ratio AD to AB to DC to BC is 5 to 12 to 6 to 5. We have to calculate the area of the trapezium showing your working. Well, the total number of parts, we've got 5 plus 12 plus 6 plus 5. We have 17, 23, we've got 28. So we've got 28. And then, if I do 56 divided by 28, well, that's equal to 2. And then we can conclude that AD is 5 times 2, which is 10. AB is 12 times 2, which is 24. DC is 6 times 2, which is 12. And then BC is 5 times by 2, which is 10. So we've got 10 here, 10 here, 24 here, and we've got 12 over here. We now need to calculate the area. Well, what we can see here is the trapezium, because these two sides are equal and the 12 is half of the 24, through symmetry, the line of symmetry will be over here. So let's just draw that again. The line of symmetry is over here. So now we need to find out the height of this trapezium. So if I find the height of the trapezium, what I need is this length, which is also going to equal the length from here to here. Okay, so that belongs there. Now this length over here will equal the difference between 12 and 24 divided by 2. So this length here is equal to 24 take away 12 divided by 2, which is equal to 6. So I've got 6 here, and I've also got 6 here. And through Pythagoras, this height over here then is equal to 8. So 10 squared take away that 6 squared is equal to 8. And of course this needs square rooting. So we've got 8. And therefore the area is 1/2 times by the sum of the two parallel sides, 12 plus 24, times by 8, 4 times by, well here we've got 36, so that's going to equal 144 centimeters squared. So we've got 144 centimeters squared.